Welcome to the exercises solution of mathematics for class 9th, new syllabus latest edition 2020-21 KPK textbook board Peshawar. It's our tutorial number 2, and in this tutorial we will solve the questions of exercise 1.2. So as we are in chapter number 1, matrices, before going into the solution of the question of exercise 1.2, let's discuss some background. This exercise will be about the types of matrices. So as we have different types of matrices, the first one is the row matrix. A matrix which has just one row, which has just one and only one row, it is called a row matrix. For example, if we have a matrix, for example 1 2, so in this matrix we have one row and two column, so only we are interested in number of rows. So if there is only one row, then that matrix will be called row matrix. For example A, B, C. So in this matrix we have only one row. Then we have a column matrix. So similarly, like row matrix, if we have a matrix having only one column, here you can see that 1 and 2. So in this matrix we have two rows and one column. Okay, so that is called the column matrix. For example A, B and C. So here again we have one column, so that is called the column matrix. We have the square matrix. So a matrix in which the number of rows is equal to the number of column, then it will be called a square matrix. For example 1 2 3 and 4. So in this matrix we have two rows and we have two columns. So in any matrix, when the number of row is equal to the number of column, then it will be called the square matrix. Then we have the rectangular matrix. So when the number of rows is not equal to the number of column, then it will be called the rectangular matrix. Mean any matrix in which the number of rows or number of columns are not equal to each other, then it will be called the rectangular matrix. For example 1 2 3 4 5 6. So in this matrix we have two rows but three columns, so it is called the rectangular matrix. Then we have the zero matrix or null matrix. So any matrix in which all elements are zero. Okay, mean when all the elements, any matrix of which all the elements or all the entries are equal to 0, it is said to be zero matrix, or it is said to be null matrix. For example this one 0 0, so it is a null matrix, it is a column null matrix. Okay, mean all the element of zero matrix, all the elements of zero matrix will be 0. Okay, then we have the diagonal matrix. So see, these elements are called the diagonal elements. Here you can see that 1 and 4, here 0 and 0, these are the diagonal elements. For example we have 1 0 0 4. Okay, so if a square matrix, mean the number of rows must be equal to the number of column. If in a square matrix all the elements are 0 except the diagonal elements, these are called the diagonal elements. Okay, these are called the diagonal elements. For example 1 0 0 0 2 0 0 0 3. So here you can see that this is 3 by 3 matrix in which we have 3 rows and we have 3 columns. So that is a square matrix, and except the diagonal elements all the other elements are 0, so that is called the diagonal matrix. Then we have the scalar matrix. So a square matrix in which all the elements on the main diagonal are equal. Mean for example if all the element on the diagonal are equal, for example 2 0 0 and 2, so this is the main diagonal in which the element are equal and the rest of the element will be 0, then it is called the scalar matrix. Okay, also you can see that for example 3 0 0 0 3 0 0 0 3. So here you can see that on the main diagonal all elements are equal and the rest of the elements are 0, so that is called the scalar matrix. And now a scalar matrix in which the main diagonal, on the main diagonal all elements are equal to 1 and the rest of the elements are 0, then it is called the identity matrix. For example, 1 0 0 1. So this is a square matrix and on the main diagonal all the elements are equal to 1 and the rest of the elements are 0. Also 1 0 0 0 1 0 0 0 1. So this is also an identity matrix. Okay, then we have the transpose matrix. Okay, transpose of a matrix. See, for example, if we have A, B, C and D, for example, this is a matrix A. Okay, so the transpose of this matrix will be written as A to the power T. This is representing the transpose of the matrix. Now convert the column into row AC, convert this column into another row. Okay, so this will be the transpose of A matrix. Okay, suppose we have a matrix A of any given order, then the matrix obtained by interchanging mutually the rows and column, then it will be called the transpose matrix. Then we have the symmetric matrix. See, for example, if we have a matrix 1 2 2 and 4, for example, we have this matrix B. And if we take the transpose of this matrix, see, if we take the transpose of this matrix, it will be 1 2, convert this column into row, convert this column, exchange this column into row. So see, the original matrix is equal to its transpose, so it is called the symmetric matrix. Second one, we have the skew-symmetric matrix. For example, if we have a matrix 0, suppose -3 3 and 0, suppose we have this one matrix, that is C. Okay, now take the transpose of this matrix. Transpose mean interchange this column by row and interchange this column by another row. Okay, so now that is the transpose. Now if we take minus out from this matrix, it will be 0 -3 3 and 0, it will be minus negative of the transpose. So see, now the negative of the transpose is equal to the original matrix, then it is called the skew-symmetric matrix. Okay, so these are the different types of the matrices. Now let's come into exercise 1.2. Question number 1. Write the transpose of the following matrices. So the first one, the transpose of the matrix P will be equal to convert interchange the row into column. So this column interchange into row and another column, this 2 1 into another row. So this is the transpose of P. Similarly, the transpose of the second one, its transpose will be equal to interchange this column into row, that is LN, interchange this column into row, that will be MP. So this is the transpose. Similarly, the transpose of third one, that is one row and one column, so it will be itself, it will be equal to itself. So see, here the transpose is equal to the original matrix, so it can be called the symmetric matrix. Now the transpose of this one, transpose of ST, that is equal to convert this column into row, -5 -2 4 1 1 4, that is the transpose. Similarly, the transpose of this matrix T transpose, the transpose of this matrix T, convert this column into row, that is 6 13 2, convert this column into row, that is 7 1 4, convert this column into row, that is 8 3 and 5. So that is the transpose. Okay, question number 2. Which of the following matrices are transpose of each other? So here you can see that A1, 2, that is the row, A1, 2, that is the column, B1, B2, that is the row, B1, B2, that is the column. It means that these rows are interchanged into the column. So it means that we can say that B is the transpose of A. Okay, also we can say that A is the transpose of B. Mean these two matrices, the elements are mutually interchanged. Here you can see that the row of C is this one, and here the column of D is this one, and the row of C, this one, is equal to the column of D of this one. So it means that D is the transpose of C, or C is the transpose of D. So that is the solution. Question number 3. Which of the following matrices are symmetric? So just we have to take the transpose. So see, the transpose of matrix A is equal to, convert this column into row, so it will be 5 minus 1, convert this column into row, that will be minus 7 into 5. So here you can see that the A is not equal to the transpose of A. So this is not a symmetric matrix. Okay, now take these the transpose of B. So the transpose of B will be equal to, convert this column into row. Okay, convert this column into row. So now you can see that the B matrix is equal to its transpose. So this is a symmetric matrix. Okay, similarly take the transpose of C, transpose of this matrix. So interchange this column by row, 3, 5, interchange this column by row, 4, 6. Again the C matrix is not equal to its transpose, so this is not a symmetrical matrix. Okay, similarly take the transpose of D. So D transpose will be equal to, convert this column into row, that will be 1, 2, 3, convert this column this row into column, that will be 4, 5, 6. Again the D matrix is not equal to its transpose, so this is also a non-symmetric, this is not a symmetric matrix. Okay, so only B is a symmetric matrix. Similarly, come to question number 4. Which of the following matrices are skew-symmetric? So we have to take the transpose, and then we will take out the negative sign out, so then we will look into it. See, for example, for question 1, the A transpose will be equal to, convert this row into column, that is 0, 4, convert this row into column, that is minus 4, 0. Now take the negative of the this matrix, this transpose matrix, so it will be 0, 4, minus 4 and 0. Okay, so now you can see that the original matrix is equal to the negative of the transpose matrix, so this is a skew-symmetric. Okay, similarly take the transpose of B. So the transpose of B is equal to, we can say that, convert this row into column, that will be 0, minus 5, that will be, convert this row into column, that will be 5 into 0. Now take out the negative of this transpose. Okay, so minus B transpose will be equal to 0, minus 5, 5 and 0. So here you can see that the B matrix is equal to the negative of its transpose, so it is also a skew-symmetric matrix. Okay, now for C, C transpose is equal to, convert this column into row, 0, 7, convert this column into row, 7, 0. Now take the negative, minus negative of the transpose. So if we take the negative, it will become 0, minus 7, minus 7, 0. So it means that C is not equal to the negative of its transpose, so this is not a skew-symmetric matrix. Okay, similarly take the transpose of this D matrix. so its transpose will be convert this row into column 0 3 2, convert this row into column, that will be -3 0 1, convert this row into column, that will be -2 -1 and 0. Now take the negative of this matrix, this transposed matrix, so that will be 0, that will be 3, that will be 2, this will be -3, this will be 0, this will be 1, this will be -2, this will be -1, this will be 0. Now you can see that D is equal to, the D matrix is equal to the negative of its transpose, so this is also a skew symmetric matrix. So A, B and D matrix, these are the skew symmetrics, and C is not a skew symmetric matrix. So this is all about the exercise 1.2. Thank you for watching. Subscribe the channel for more videos and comment if you have any question or suggestion. Share with your friend. Thank you.